Hello. Right, this lesson or this video, we're going to look at similar areas and volumes. So we said that when you are looking at kind of enlargements and similar shapes, then we use the scale factor. But something interesting, or I think it's interesting, happens when you look at the areas and volumes of similar shapes. So this little blue triangle here has been enlarged by a scale factor of 3 to get this big pink triangle. So we're going to look at the lengths first because we know what to do there. So if this length here is 2, this is our corresponding length. So we multiply it by 3 to get the new length. So 2 times 3 is 6 centimeters. The base, again, they correspond. So we have a 3 here and we're trying to work out this one. So we times 3 by 3 gives us 9 centimeters for the base of our enlarged triangle. Now for the area, we're going to calculate them for both and then see if we can see what's happening. So for the first one, the blue one, we're doing a half base times height divided by 2. So 2 times 3 divided by 2. So 2 times 3 is 6, divided by 2 is 3. So that's 3 centimeters squared for our area of the first triangle. The second one, we're going to do the same again. So we're going to do base times height, 9 times 6 divided by 2 is 27. Yeah, 27 centimeters cubed. So you can see straight away that we haven't enlarged it by a scale factor of 3 this time. We've gone from 3 to 27. Okay, so what has happened? So for length, the scale factor, we just multiply by the scale factor. For area, to get from 3 to 27, we've multiplied by 9. If we are good at our square numbers, we should know that 9 is 3 squared. So for area, we have multiplied by the scale factor squared. And when we think about it, it kind of makes sense. So the units are all squared now. Oh, I wrote cube there. That should be squared. Oh, that's too big. No, that's better. Centimeters squared. The units are squared. So it kind of makes sense that the scale factor also has to be squared to enlarge the area. Okay, so that's the main thing that we need to keep in mind for this lesson. Put it on the next slide. So for area, the scale factor is squared. So whatever the scale factor is, to work from one area to another, we have to square the scale factor. And for volume, because again, units for volume are like centimeters cubed or meters cubed. So again, it follows and it makes sense that the scale factor has to be cubed because our units are cubed. Okay, I'm going to show you four examples. Yeah, 4 examples of how we can use that so that you can kind of see it in action. And I would tend to use a table. So let's just get started. A shape X is enlarged by a scale factor of 5 to produce shape Y. The area of shape X is 3 meters squared. It wouldn't let me type a proper squared, so I've just put a big 2, but it means squared. 3 meters squared. What is the area of shape Y? So I'm going to do myself a little table here. I should have used straight lines. Yes, so this is shape X. This is shape Y. For the length, we multiply by the scale factor, which is 5. We don't know the length, though. For area, we are going to multiply by 5 squared. Okay, so if the area starts off as 3, to get shape Y, we are going to times 3 by 5 squared. We're going to times 3 by 25, which is 75, and we are working in meters squared. So the area of the enlarged shape is 75 because we have multiplied the original area by the scale factor squared because it's area, and that gives us our answer. Okay, so let's have a look at the next one, which might be a little bit different. So I'm still going to use the table. I'm still going to have length and area within the table because that's what we're talking about here. It's surface area, but still area. So shape A is enlarged to form shape B. The surface area of A is 30 centimetres squared and the surface area of B is 120 centimetres squared. If shape A has length 5, what length does shape B have? So to get from shape A to B with the area, we have taken our 30 centimetres squared and it's turned into 120 centimetres squared. To get from 30 to 120, we have multiplied by 4. Okay, but remember that the scale factor has already been squared. Okay, so to get the length, we need to work out what the original scale factor was before we squared it. So we had something, we had a scale factor, we squared it, and we got 4. To work out what the scale factor is, we have to do the opposite of squaring. So we have to square root. So we have to square root 4, which would give us the original scale factor. So the square root of 4 is 2, because 2 times 2 is 4. So that means we have to times 5 only by 2 to get the length of B. So 5 times 2 is 10. So 10 centimetres, because it's a length. And that is our answer. Okay, so you do have to watch out for those types of questions. Really, really common mistake is that you would times 5 by 4, because that's what you've times the area by. But you have to remember that that 4 is already the scale factor squared, so you have to reverse that squared to work out what the original scale factor actually was. Hope that makes sense. The next question is kind of similar, but using volumes as well. So shape A is enlarged to form shape B. The surface area of A is 30 centimetres squared and the surface area of B is 270 centimetres squared. If the volume of A is 80, what is the volume of shape B? So I'm going to make my table again, but this time I'm putting length, area and volume because I need all three to be able to work out this question. Length, area and volume. This is shape A, this is shape B. So to get the length, we multiply by the scale factor. To get the area, we multiply by the scale factor squared. To get the volume, we multiply by the scale factor cubed. So we know the areas are 30 and 270. And to get from 30 to 270, we have multiplied by 9. And we need to work out the volume of shape B if we know shape A is 80. But again, what we have to remember is we have the scale factor squared, which is 9. So we need to work out what just the scale factor is to be able to then use it to work out the scale factor cubed. So we have to go backwards before we can actually work out the cubed version of the scale factor. So the first thing I'm going to do is square root 9 to get what the original scale factor is, okay, which is 3, because again, we knew the scale factor squared. We have to reverse that to find what just the basic scale factor is. So we square root 9. The square root of 9 is 3. And then we need to, for volume, we need to multiply by the scale factor cubed. So I have to, not times it, I have to cube it. It's hard to tell that it's a cubed, isn't it? 3 cubed is 27. Okay, 3 times 3 times 3 is 27. So that is what I need to multiply by that 80 by to find the enlarged volume. So I have to do, and I'm going to have to do it on my calculator, 80 multiplied by 27, which is 2,160 centimetres cubed. And that is my answer. That's it. Okay. And that's it. Again, for each question, it's very rare that you can do it without knowing what the basic scale factor is. So whether you know what it is cubed or squared already, you will all usually, I'm going to go ahead and say always, have to work out what the basic linear scale factor is first, and then you can square it or cube it to work out whatever piece of information you need. We have one more example where again we need to do something with the volume and the surface area. So I'm going to draw my table. A, B, length, area, volume. This time we've been given the volume. So we know the volume of the A is 10 and we know the volume of B is 640. I'm going to put them straight into my table. 10, 640. We need to work out the surface area of B. So the surface area of A is 20 and we need to work out B. Not sure how you can have an area that's smaller than... No, never mind. So, how have we gotten from the volume of A to the volume of B? To get from 10 to 640, you've multiplied by 64. Okay? If you're not sure how I'm doing that, I'm just dividing. I'm doing the 640 divided by 10 to work out what this part is here. So I'm timesing 10 by 64 to get 640. Now this time, that is my scale factor cubed because that is the volume. So the scale factor cubed is 64. I need to find just the scale factor and I have to do the same thing again. I have to root it, but this time because it's a cubed, I have to cube root the scale factor in order to get the original one. So I have to do the cubed root of 64, which you can do on your calculator, is 4. 4 times 4 times 4 makes 64. So my basic scale factor is just 4. So that means to work out the length, if I was asked to, which I'm not, I would multiply by 4. And then I can use that to work out my scale factor for area. So I have to times by 4 squared. 4 squared, 4 times 4 is 16. So to find the area, I need to do 20 multiplied by 16, which is 320 centimeters squared. And that's my answer. Okay, so it's a similar thing again, working out the scale factor that you've got and then rooting it, either square rooting it or cube rooting it, depending on whether it's area or volume, to work out what the basic scale factor was, and then either squaring it or cubing it to work out the missing piece of information. In this case, it was the missing area of B. I hope that makes sense. I hope you followed along. I hope it makes sense. I hope it helps. Have a lovely day, and thanks for listening along. Thank you.